Hello, astronomy enthusiasts from all over the world. My name is Luis Miguel Azurin, and I welcome you to a new video from Astroacademy. Last week, we already announced an important and exciting piece of news on our Astroacademy podcast. Our innovation hub, the MPC Observatory, has obtained the MPC code issued by the Minor Planet Center, which certifies that the observatory and its equipment are qualified to obtain precise astrometric measurements of minor bodies in the solar system, such as asteroids, comets, or dwarf planets. These measurements are then reported to the Minor Planet Center itself to refine the orbits of these objects or to detect variations in them. Would you also like to know how you can obtain this observatory code and not only use your astrophotography equipment to capture spectacular images of the night sky, but also to contribute data to science? In this video, I'm going to explain to you step by step how you can get your own MPC code, from the requirements your observatory must meet to how to plan your observations, take measurements, and submit your final application to the MPC. If you're interested in astrometry and want your observations of asteroids or comets to be included in the official database, this video is for you. What is the MPC and what is an MPC code? The Minor Planet Center, or MPC, is the international organization responsible for collecting and validating observations of asteroids, comets, and minor bodies in the solar system. Every observatory that submits precise astrometric measurements can obtain an MPC code, a unique identifier that officially recognizes your observations within the global network. Having an MPC code means your data can be used in orbital calculations, scientific publications, and official discoveries. It's not just a number. It's the validation that your observatory meets the standards of accuracy and reliability required at the international level. The MPC requires certain minimum standards to grant a code. First, you must demonstrate that your observatory is capable of making precise astrometric measurements with errors of less than 1 arcsecond in position. Additionally, the observatory must be stable and permanent. That is, it must have well-defined geographic coordinates, not move from one place to another, and be able to maintain a reproducible observation setup. In short, a setup that systematically allows you to obtain reliable measurements always from the same location. Does this mean you need to have a permanent physical observatory? Actually, no. The only thing the MPC requires is that the observation position is always the same, so your garden, terrace, or balcony could perfectly well be a valid observatory for the MPC. On the other hand, the MPC recommends that your observations be made of objects from the MPC catalog, either numbered asteroids or those provisionally designated, or of comets. But to obtain the MPC code, it's not only necessary to get high-quality astrometric measurements of the objects designated by the MPC, but also to obtain these measurements on a specific type of objects, NEAs, or near-Earth asteroids. These are asteroids close to Earth that should be monitored regularly because they can pose a potential threat to our planet. The requirement to be eligible for obtaining the MPC code is to measure 10 NEA asteroids with a magnitude fainter than 16 on 2 different nights separated by less than a week. It is not necessary to obtain measurements of all 10 NEAs on the same night, but it is important that the observations are not separated by more than a week, and obviously that we have a plan for our observations so that the process does not drag on for months. Otherwise, the MPC could reject our report. Therefore, to ensure success, it is highly recommended to have good planning. Once you have your equipment ready, it's time to plan your observations. The first step is to select which asteroids to observe. There are multiple software options for this. Cartes du Ciel can be a good option since we can load it with databases of asteroids of different magnitudes and identify those that are within reach during our observation nights. Stellarium can also be a useful alternative since, similar to Cartes du Ciel, we can also load it with asteroid databases and monitor their movement throughout the nights. The MPC's own website has a search tool through which we can check, given our geographic coordinates, which NEA asteroids of special scientific interest will be within our reach during the night. This can be a very good option since we are not only going to work on asteroid astrometry, but we will do so with numbered asteroids that are of special interest to the MPC. However, we will notice that the magnitudes of these asteroids proposed by the MPC are extremely faint for the most part, which means we will need to work with very powerful equipment. In our personal experience at the MPC Observatory, we have found Julio Castellano's Orbitas software to be especially useful. This free software, developed by this amateur enthusiast from Valencia, can be downloaded from his website. Through this program, we can access complete lists of different minor bodies in the solar system, including NEAs. We can look up all the data for each object, such as magnitude, coordinates, orbital data, and more. Visibility throughout the year, and even the maximum exposure time for our capture, depending on the resolution of our equipment. It was by combining the information provided by the MPC search tool with the Orbitas software that we put together our list of 10 NEA objects to obtain our code. And finally, to capture the images, we used NEA. The orbital script with L in this software allows us to search for multiple objects in the solar system. Then transfer their coordinates for our observation night to an advanced capture sequence where we will have the entire night's observation planned out. It is recommended to capture images of the same object over periods of between 30 and 60 minutes. Depending on the speed at which our asteroid is moving, we will be able to properly cover its apparent motion, which will make our measurements easier. Now, let's see what equipment you need. The minimum equipment includes a telescope, a cooled CCD or CMOS camera, and a mount capable of maintaining precise tracking for several minutes. As for size, telescopes between 8 and 10 inches will allow you to easily reach fainter magnitudes. However, this will be directly related to the quality of the sky at your observatory. If the sky quality is high, you'll be able to obtain quality astrometric measurements with much smaller telescopes. As a reference, I'll tell you that the MPC code for the Astrogrados Observatory was obtained with a 90mm aperture apochromatic refractor telescope, 500mm focal length, a color CMOS camera with an APS-C sensor, and a Skywatcher HEQ5 Pro equatorial mount. It's really a small setup, but with a very high-quality dark sky, which has allowed us to achieve consistent precision in our measurements below half an arcsecond. While the limit set by the MPC is 1 arcsecond, the camera is key in this field. Sensors with pixels between 3 and 6 microns and low read noise will be ideal. Guiding and mount precision are another key point. Whether you use an off-axis guider or a parallel guide scope, it's important that your guiding is precise and doesn't distort the stars, so that the measurements are optimal. And of course, the observatory must have a precisely determined geographic position, preferably using a GPS receiver or online services like Google Earth with verified coordinates. Once the images have been obtained, the most important part comes: reduction and astrometric measurement. For this, you will need specialized software such as Astrometrica, Tycho Tracker, or PixInsight with the Astrometry module. The process consists of calibrating the images with darks, flats, and bias or dark flats. Solving the star field using a reference catalog, for example Gaia DR2 or DR3, and measuring the position of the object in each frame. The results must be expressed in J2000 equatorial coordinates along with the exact moment of the observation in UTC time. From there, the astrometric software generates a file in ADES format, Astrometry Data Exchange Standard, which is the format currently accepted by the MPC. In our case, we have carried out all the reductions and measurements with the Tycho Tracker software, a very comprehensive tool that not only allows you to perform astrometry, but also photometry. Would you like to see more content about this kind of software here on Astroacademy? Let me know down in the comments. The MPC expects your measurements to have a positional accuracy better than 1 arcsecond and a timing accuracy of less than 1 second. It's also important that the measurements are consistent across different nights. If the MPC detects systematic errors, for example a constant offset in right ascension, it will probably ask you to make corrections before assigning you the code. That's why it's highly recommended to compare your results with precise ephemerides and to monitor the residuals of your data, that is, the deviations compared to data obtained by other observatories. Tycho Tracker allows you to access these lists and check whether your measurements fall within the margins or not. Once you have gathered all your observations, you will need to transfer them into a single ADES report. And this will be the report you must send to the MPC for validation and for the issuance of the code for your observatory, if they consider it correct. On the MPC website, you have all the information needed to carry out this process, including instructions for submitting all the data, the code request form, and the section to send the report. In the description of this video, we have provided a direct link to this section of the MPC website. In any case, if you have any questions about this, you can write to us and we will be happy to help you. The MPC will review your data, and if the accuracy of your measurements meets the requirements, they will issue your MPC code and send it to you by email after a few days. From that moment on, you will be ready to load your MPC code into your measurement software and start using it in the reports you send to the MPC. Obtaining an MPC code is not difficult, but it does require rigor and consistency. It is a recognition that places your observatory within the international community of observers and directly contributes to astronomical science. If you are passionate about astrophotography, but also about astrometry or photometry, I invite you to continue learning with us. At Astroacademy, you will find new content and tutorials so that your observations become increasingly precise and useful to the scientific community. See you in the next video, and until then, clear skies.